After the site preparation, we're now going to begin on the foundation. And this is an area that could change quite a bit from state to state. Now, the basics, I think, are about the same. In the rest of the home framing and everything else, it's kind of the same throughout the country. But the foundation is where you're going to see some possible major variations from state to state. I know as you get into Texas, because of some of their soil in parts of Texas, they refer to it as gumbo. It kind of moves and gives and can create some serious foundation problems if it's not addressed correctly. As you get in parts of California, because of earthquakes, they have issues they've got to deal with on building the foundation. So it's going to require that you do a little homework in your given area and find out, things about the foundation that pertain to your area. But the basic part that I'm going to be talking about is going to be pretty much the same. And then you'll have to add to this depending on your location because of soil conditions and earthquakes and stuff like this. So let's go ahead and get started on the foundation. Now, I'm going to be a little redundant here because I'm going to talk about a crawl space. Most of you know what a crawl space is. That's where you don't have a full basement, but you can get under the home. And then after we do the crawl space, we'll talk about a full basement. Now, both of them are pretty much the same up to a given point. So it may be a little bit of redundancy, but I think that'll keep us kind of squared away and straight, so we don't get too confused. So we're going to talk about the crawl space. Now, the grader kind of cleared and prepared the land for the crawl space according to your site plan. And there's things the grader will know to do in order to get it prepared for the crawl space. And on the crawl space, you're going to be dealing with a subcontractor, and I recommend you go with poured walls on the crawl space. You may or may not want to go with concrete block walls. If you go with concrete block walls, you'll still go through this process. But I tell you, if you compare apples with apples, you might see for a nickel more, you can go with a poured wall. And on the poured wall, you're dealing with a subcontractor. You're not dealing with a mason, which is labor. It makes life a lot easier. And I think you have a much more quality job by going with the poured concrete wall. And this subcontractor will do everything I'm going to mention here. They will get in and they will lay out the location of the walls and footings based on what your surveyor staked in the ground. So they'll lay out the location of these footings, and the footing is the foundation of the foundation. And in these footings, I recommend you put steel in the footings so that should the footings ever crack, the steel holds it together. And in the steel in the footings, in more and more areas, the inspectors are requiring that you turn a rod up from the steel in the footings, and that rod will eventually go up through the foundation wall, and that's going to be the grounding rod for your electrical service. I'm seeing in more and more areas, the inspectors are wanting you to tie the electrical rod into the foundation footing steel instead of putting a grounding rod outside as we used to always do. You can find out what they're doing in your area, and whatever they're doing, that's what you want to do. But I wanted you to be aware of this. And if you'll get with your electrician to look at your drawings, kind of find out where he thinks he would like to have the panel, the service panel for the home, where you cut the circuit breakers on and off, and you would prefer positioning this rod fairly close to where that service panel is going to be located, just to minimize the distance that you've got to run copper wiring from the service panel to this grounding rod location. But your poured foundation sub will lay out the location of the foundation based on what the surveyor showed. They will lay out the footings, and depending on where you are in the country, they may dig a trench in the ground, which will become the footings, or they may form the footings up on top of the ground if you're in an area where the soil is not conducive to dig a trench in it. You'll see pictures of both of these. After they form the footings and they get the steel in the footings, you'll normally have the building inspector come out and inspect the footings because they want to make sure you're not pouring on top of mud. You never want to pour concrete on top of mud. They want to make sure you're not pouring on unstable ground. And they'll be concerned if you're pouring on top of rock. And after you pass this footing inspection, they will authorize you to pour the concrete in the trench for the footings. Regarding this inspection, it probably will not be a problem right now because things are pretty slow nationwide. In that if you call the inspector that morning, he'll be there that day to inspect the footing. And this can be critical if you're concerned about there's going to be rain in the afternoon and you do not want it to rain in that footing trench, or you'll be in there trying to get the mud out of the trench. Now, you don't have to get all the mud out, and we call it mucking it. You don't have to get all the mud out, but you want most of it out. And so you want the inspector to get there, get the inspection done so you can get this footing poured, especially if rain is in the forecast. Now, in times when there was a lot of building going on and the inspectors were just covered up, it could be a problem getting them there in a timely manner. So check with your inspector to see if they allow you to hire outside engineers to come in, inspect the job, sign off on it, and they'll give this signed letter. You'll give this signed letter by a professional engineer to the inspector, and the inspector, that satisfies them so you can continue forward with the construction of your home. I personally would prefer they let me hire engineers to do all the inspections throughout the home instead of having to fool with the inspectors. Yes, it costs a little more money. It's not an outrageous amount of money, but in some ways, I feel the engineers do a little better job than the city or county inspectors. And the big thing is they get there when I need them. I'm not sitting around waiting on an inspector. Now, in some areas, the inspectors will not allow this, but in some areas they will. And if they will, that could make your job a little easier and the workflow a little smoother. While we're talking about pouring concrete, I want to go ahead and tell you something about concrete. And this is probably more than you care to know. I just want you to be aware of it. Concrete is very, very strong, and it is very, very brittle. Just a slight movement in concrete can cause it to crack. Now, I have heard that they have been working and developing on the West Coast primarily what they call flexible concrete, which will be great in earthquake areas. I just cannot imagine, boy, what a wonderful thing. I can't imagine what it may cost when they do have it available. And it may be even available now because I first heard about this a number of years ago. Flexible concrete. But until you're aware of this or you have availability of this, concrete is pretty darn rigid and can easily crack with any movement. Concrete by nature, because it expands and contracts, will develop cracks in it. As a matter of fact, the only lifetime guarantee I can give a homeowner in writing is that your concrete is going to crack. Guaranteed. Lifetime guarantee. Now, because of this cracking, we put steel in the concrete so that when it cracks, the concrete won't separate, which will create a problem. As you get into commercial work, we'll even put more steel in it, especially if we're building a high-rise building. As you get into nuclear reactors, you cannot imagine. It looks like there's more steel in the wall than concrete. Because what's going to happen is the concrete will still crack, but the steel holds it together. And the more steel you have, the crack is so microscopic you couldn't see it except under a microscope. We don't have to be worried about that in a residential home. However, we do want to minimize any footings or walls separating when it cracks. So we do like to put steel in the footings, and we like to put steel in the wall. That's one reason you don't want to pour concrete on top of mud, is because as the mud dries out, it will shrink, and that shrinking can cause some slight movement in the concrete and cause it to crack. Now, if you get mud in a footing, you don't have to get out every speck of mud. You just get the bulk of it out before you pour the concrete in there. But you don't have to have every little speck out. Don't get that carried away. In the scriptures, it says to build your foundation on rock. Well, that's good if you do it correctly, because rock picks up vibrations in the earth, and those vibrations can destroy a foundation over time. Also, when you pour concrete on top of rock, if there's not a good bond there, the footing, for example, could slide on the rock. So there are several things you need to do to correctly pour concrete on top of rock. A lot of times when you're digging for a foundation, for example, part of the foundation may be on solid rock and part of it's on earth. Well, where the rock and earth meet, the rock, as it implies, is pretty solid, where the earth will tend to give a little bit. And where the rock and earth meet, that is a stress point that needs to be addressed, or you're going to have a major crack there that could create a problem for you. If you're building just the basic home, your poured foundation sub, they will know how much steel to put in the footing, in the walls. If you tell them you want steel in the footings, in the walls, you can see sketches where we hired engineers at 24/7 and see what they recommended. But if you're getting into a large foundation, then the person that you need to hire to address the things I just issued is a structural engineer. Now, shop around. You shouldn't pay an arm and a leg for this. And the structural engineer can show you how much steel they recommend you put in the footing for your home. They can recommend the size and the amount of steel you put in the walls for your home. And they can tell you how to address any problems, such as if part of your foundation is on top of rock, they'll tell you what to do there so you don't have any issues with the rock. And if you wind up, you're digging for a foundation and the soil is just not any good, what you'll do in a situation like that is you can get with a soil engineer and look in the yellow pages under engineer, and you'll see soil engineer, civil engineer, structural engineer. But shop around in the industry, and because prices go from A to Z, and find people that work with builders on a regular basis and their prices are pretty fair. And the soil engineer can come out there if you have any questions about soil, and they can test the soil and tell you, yes, this is fine for your foundation. Or they can say, no, this could be a problem. And the soil engineer could venture into saying, you could possibly do this, and correct it, but more than likely the soil engineer, what they can do is tell you how stable that soil is. And what you can do now is give that information to a structural engineer, and the structural engineer can design your footing and foundation wall on top of that unstable soil, so that if you run into a soil issue or unstable ground, no problem, as long as the structural engineer, for example, knows the quality of the soil, and they can design your foundation, footing, and wall to sit on top of this unstable ground, and you have no problem in the future. I mean, there are places in the country where they build on top of swampland, where they build on top of sand. There's no stable ground, and it works just fine as long as it's done correctly. But anytime you've got a structural issue, always deal with a structural engineer. For those of you that are remodeling, if you want to go into an old home and tear a wall out to open up a room, get a structural engineer in there. Because first of all, if you don't have any experience, they can look and say, well, this is what we call a load-bearing wall. You just can't tear this wall out without putting back some support. And you want to look at the structural engineer and say, okay, I'll design it on how to put support back, but keep my cost to a minimum. And they can show you what you can do to open this room up and not create a structural issue. Now, don't necessarily hire an architect, because the architect will sub it out to a structural engineer. But especially if you're building a large home, the structural engineer could even recommend and dictate the size material, the type and size of material you use in your home for structural reasons, where you have these big open rooms. As you get into larger homes, I think it's a good idea to have a structural engineer, to pay them a fee to review your drawings. And what they're going to be able to see are areas of the home where you have excessive loads. And they will give you sketches on how those areas should be addressed, how they should be constructed, so those heavy loads aren't going to be an issue in the future. They may show you in a given area your footing needs to be a little larger here because there's a chimney sitting on it or something to this effect. And the structural engineer can review your drawings and give you these recommendations, and I think it's money well spent. But I know over the years, I've run into problems, and through my common sense, I would figure out, well, we could solve the problem this way. And so we would tear something out, rebuild it, and it didn't solve the problem. Then I would talk with the sub, and the sub would say, oh yeah, you should have done this and this and this. So we would tear it out, rebuild it according to what the sub said, and I would still have a problem. Then the supplier would get in on it. He said, yeah, you and the sub, you weren't thinking correctly, and this is what should have been done. So we would tear it out and redo it as the supplier indicated, and we still had a problem. So out of frustration, I would then go to a structural engineer, let them see what the issue was, and they would design a solution to the problem. And I'm telling you, in every single case, they always solved my problem. For that reason, anytime I run into an issue that I'm not crystal clear, I know the solution to the problem, I don't talk to the sub. I don't talk to the supplier. I go directly to the structural engineer to solve my problem. This is a very cheap insurance policy, because one thing you do not want in the future is a foundation problem. Those are very expensive problems to fix. And along the same line, I remember I had a student that had an existing home and she developed what she thought was a foundation problem. She called several companies in and they gave her bids that were tens of thousands of dollars to fix what she thought was a problem. I told her to call a structural engineer before she made a decision. Let the structural come in, look at the situation, and tell her how he thinks the problem should be solved. And he can give her sketches or whatever so she can now go out and have people bid on it. Well, the structural came in, and what he found out is she didn't really have a problem. It was just a aesthetic, visual issue. And she was able to fix it for just a matter of a few $100s instead of paying tens of thousands of dollars. So anytime you've got a structural issue, go ahead, contact. Because if you're building, for example, a large retaining wall, and that sub says, oh yeah, I've built hundreds of them, know exactly what to do. And you build that thing and it caves in, then you're going to be forced to get out there and get all that debris out, a lot of money. Then you may be in a lawsuit situation and you're going to be mandated by the court to hire a structural to redesign it and get it built correctly. So just go ahead and deal with a structural engineer up front to avoid those issues. A very cheap insurance policy. I'm really sorry to labor that part so much, but I just want to just drive it into you that on doing these things, because I've been there, I've done that, I've made these mistakes, I've spent all this money, and I just hate to see you go down those roads I went down when you can hire some of these professionals that will just keep you out of a world of trouble. Okay, so let's get started back. The poured foundation sub, we got an inspection on the footing. They poured the concrete in the footing. After they pour the footing, it's going to set up overnight, and the next day they can start setting up the walls. Now, what I want you to do now is get your surveyor out there, and the surveyor will drive, he can drive nails, concrete nails, in the footings to indicate all the corners of your foundation wall. This is not only going to make it a lot easier for your foundation sub to set up the forms for the walls, because they now know where the corners are located, but if you're building on a real tight lot and you don't have any, much wiggle room, before you cross a setback line or a building line, this makes sure your foundation is right where it needs to be and you're not crossing any of these lines by having the surveyor do this. So after the surveyor marks the corners on the footings where the corners of the walls are, your foundation sub will get in there and they will form the walls. They will place any steel needed in the walls. You want to be conscious of the continuation of the grounding rod up through the wall from the footing. And you want to mark on your drawings where that foundation rod is sticking up above the wall. And the reason why you want to know is later you don't want the framing carpenter to bend it over or try and cut it off, that some of them will try and do, because it might be in their way just a little bit. And you want to know where that rod is located so you can locate it in the future and show the electrician. In some areas, the inspector will require that they come out and inspect the walls, the steel and everything in the walls, before you pour the concrete in it. And one thing I want to mention here, I talked about if the inspector wasn't available to come out and inspect the footing, hire a separate engineer to come out and do the inspection and give you a report. I would like to tell you, rookies, that you're just starting out in this industry, in the footing, there's several things to be concerned with on pouring on unstable ground as I mentioned, pouring on rock and stuff like this, even if you have an inspection department, there are firms out there that we builders hire that will come out and verify that the footing is in good condition, that you're not pouring on unstable ground. They will verify that the steel is in the footing in the correct position, and they'll walk around and check all of this before you get your footing inspection. I know how to do this, but I will now hire these companies to come out and they check it for me. And it puts me in a great position to look at the sub and say, listen, they said that you need to do this, or I'm not going to pay you. We're not going to pour the footing. So it puts me as the good guy and they're the bad guy telling the sub exactly what needs to be handled. So I would encourage you to hire these people. They can also come back after they form the walls up and they can verify that the steel in the wall is where it should be. They just didn't throw it in there, satisfying the requirement that steel's in the wall. There's places the way the steel should be structured in the wall, positioned in the wall, let me say. And these companies that you can hire, and to me, they're very inexpensive. They can check the footings, they can check the foundation wall before you proceed, and especially before you pay the sub. The poured foundation sub will now pour all the walls. And when they pour the walls, they'll have if there's adequate room, they'll get the trucks out there that will just back right up to where the forms are. If there's not adequate room for the trucks, they may get a truck out there with a conveyor belt on it. We call it creekveyor, that will convey the concrete over into the forms. Or they may get a pumper truck out there, which is very efficient. And that pumper truck will set up in one location and they will dump concrete in the back of the pumper truck. And that pumper truck will pump it up through this hose, and from that one location will pour all your walls from that one location. The creekveyor, the pumper truck, they are very, very efficient, and it costs more money to have them on the job. So if we can get it done without utilizing those trucks, I would prefer doing it, but a lot of times it's hard to do this without these trucks. When they're pouring the walls, I want you to remind the poured foundation sub that you would like for him to use a vibrator so you're minimizing what we call honeycomb in the wall. And he'll get out there, and you've got to be experienced to use a vibrator when you're pouring concrete, but they'll use a vibrator and it will minimize what I call honeycomb in the wall. I'll talk about a little later. After they pour the walls, they will go around and they will install either anchor bolts, which is what we used to always use, but what most builders use now are what we call mud seal anchors. And you'll see pictures of these at 24/7. I like the anchor bolts, but I have less problems by using the mud seal anchors. Because sometimes when they install an anchor bolt, the anchor bolt is in a place where it creates a problem for me. I don't have an issue with that with mud seal anchors. We can make those work just about anywhere. So they'll install these mud seal anchors. They'll let the wall set up overnight, and then the next day they'll strip all the forms off the walls. When they strip the forms, there's a couple of things you may see on the wall when they strip it. One thing that's very common is what we call honeycomb. You'll see pictures of this at 24/7. Now don't get all excited if you see this honeycomb. Hopefully most of the honeycomb was eliminated by using a vibrator. But if you still have any honeycomb effect on the wall, just point out to the poured foundation sub. Again, you want to have this understanding up front of things you're going to be requiring, that they need to go in with a filler patching compound and they need to fill in all this honeycomb on the wall as part of their job. No additional charge. Another thing you may see is what we call a cold joint. Now, this is a real no-no in large commercial buildings, but it does happen, and it does happen in residential. And what it is, they'll be delivering the concrete, and the first couple of trucks will show up, and they'll pour the first couple of loads, but then there's a long duration before the next truck shows up, or those trucks may have to go back and load up and come back to your job site because of where you're located. And so that first load of concrete begins to set up by the time they get the next load there and finish the pour. And when you strip the forms, you will see where the first and second pour took place because it didn't bond together just perfectly well. I don't like it, and it happens. It's no major upset in residential. But again, on that cold joint, they need to fill it in with a concrete filler. After you finish the foundation, you will have your surveyor back out there to do what we call a foundation survey. And they will draw a location of your foundation on your original survey. Some banks will not give you your first major draw until you turn in this foundation survey. And the reason why is they've had some builders put the right home on the wrong lot. They want to make sure your home is on your lot. And they want to make sure you haven't crossed the building line or the setback lines. And I saw a man do this on a 13-acre lot he built across the building line. Because if you got to tear it down, now's when to tear it down, not after the home's built. Some banks will require you to do this again after the home is completely finished, showing the location of driveways, decks, patios, turnarounds, fences. We call an as-built survey. And even though your bank may not require an as-built survey based on all the mistakes I've seen over the years, I would never buy a home, even a brand spanking new home, without an as-built survey. Another thing you want to accomplish when the surveyor is out there doing this foundation survey is to verify the foundation is constructed per the plan, that it's the correct length, it's the correct width, that you haven't crossed any building lines, any setback lines, and that the top of the wall is level. And when I say level, it needs to be plus or minus a ½ inch in level. Now, even though you may not understand that term, if you just tell the surveyor you want the top of that wall plus or minus a ½ inch in level, they'll know what you're talking about. And you're not going to pay the foundation sub until they do this foundation survey and verify that the foundation is the correct dimensions and the top of the wall is level. If it's not, the foundation company can fix it. But you want to hold back their money until you know this is okay. As they're winding up the crawl space, for example, you'll have them deliver a container to the job site. And in that container, when they strip all their forms and they strip the footings and all this stuff, it's part of their agreement that they got to clean up their mess. And if you have a container out there, they can dump all these forms and all this scrap material in the container and get the job site cleaned up really nice. Okay, let's talk about if you're going to have a basement instead of a crawl space. Now, we're going to go through basically the same things with a basement that we would on a crawl space, but there are some additions that I'll point out. I would also like to mention that if you, for some reason, you think you're trying to save money by going with a half basement instead of a full basement, I want you to really think this, because sometimes you're stuck with a half basement because when you were excavating for the basement, you hit rock and you didn't want to go to the expense of busting or blasting out rock for a full basement. So you wound up with a half basement. That's understandable. But if that's not an issue, then, I mean, for a nickel more, you can have a full basement. And I just cannot imagine you stopping with a half basement when you could have easily had a full one. So really rethink that if that's where you're coming from. Unless there's some real reason it needs to be a half basement, which I have a hard time imagining. But again, your surveyor has laid out the location of the foundation walls. You're dealing with a subcontractor. They will go out and, based on what the surveyor put down, they will lay out the location of the footings. They will dig and form the footings. And one thing I do want to mention here, I told you in some parts of the country they will dig trenches in the ground for the footings. Well, if you were going to build a concrete block wall, like, for example, if you were in Georgia, we've got this firm red clay, you would just dig a trench in the ground and you would pour the footing concrete in that trench, and then the mason would start his concrete block on top of that footing. And if the footing's not perfectly level, it's no big problem. The mason could level up his block and get the wall just right. On a poured wall, they want that footing to be pretty darn near level, because when they put the forms up there for the walls, it creates a problem if the footing's not nice and level. So what they do on a poured wall is they will form up, they'll form up the top 3.5 inches, because that's what they use as a 2x4. The 2x4 is 3.5 inches wide. They'll form up the top with a 2x4, which is 3.5 inches, and then they will dig down into the ground the remainder of the footing. But they want the top of that footing nice and level so that when they put their forms up there, they don't have any issues with the forms. So that's why you see in poured concrete work, they form up the footing, where in a concrete block wall, they just dig a trench, pour the concrete in the trench, and go with it. I really have no plans to really mention building a wall out of concrete block, especially on a basement. Now, we used to, when I started building, we used concrete block. But your poured concrete wall, structurally, it is far stronger than a concrete block wall. To a degree, it's already watertight, where a block wall, all those little pores in concrete block, you have got to seriously waterproof a block wall. And if you really compared apples with apples, a poured concrete wall and a block wall, you're going to see that there's, money-wise, not that much difference between the two. So I would tell students, even if it was $5,000 difference, I would pay the $5,000 to go with a poured concrete wall instead of a block wall. But fortunately, you're not going to see that kind of monetary difference. If for some reason you did, provided you are honestly looking at the block wall being constructed correctly, you may want to rethink it. But I tell you what, I have found there's hardly any difference in price, not enough to warrant going with concrete block. Also on concrete block, they'll install what we call batter boards. And this is a combination of boards and strings that show the location of the footing and the foundation wall. Normally, they do not install batter boards on a poured wall, just a concrete block wall. And you can see pictures of these batter boards at 24/7. But getting back to the basement wall, they will form and dig the footings. They'll put the steel in the footings. You'll make sure you have your ground rod turned up. You'll get an inspection on the footing. After you pass the inspection, they will pour the footings. After they pour the footings, you'll have your surveyor go out there and they will put some concrete nails in the footing, marking the corners of the foundation. After they mark the foundation, you'll have your poured foundation sub go out there and they will form up all the walls and they will place any steel in the walls that's required. And hopefully you have a structural drawing showing how the steel should be put in the walls. While we're talking about the walls, back when we were getting our plans, I want to refresh your memory and remind you, we talked about if you're going to finish off the basement level, we call the terrace level, and you want more than the old 8-foot ceiling, which really seems short nowadays, and you want a 9 or 10-foot ceiling, then your foundation wall needs to be like 10 to 12 feet high, so you've got adequate room to install those plumbing pipes, those heating and air duct, and then when you lower down below those pipes, you still got a good 9, 10, or 12-foot ceiling, depending on what you want. So I like the higher walls, but this needs to be part of your plan so you're not making this decision right now. Also, if you remember, I talked about having your T-walls or brackets underneath your masonry porches and steps. Your poured foundation sub, this should have been on the drawings, and you want to make sure the poured foundation sub is installing these T-walls and or brackets that will be underneath your masonry porches and steps so that when the ground settles in the future, those porches and or steps will not pull away from the home. Another thing that I would like to mention is when you're forming up the walls, the poured foundation sub is going to install what we call brick ledges. When you brick a home or you're putting in real stone, that's heavy and needs support, you don't want to start it down on the footing necessarily. That's a waste of good stone or brick underground. So what you do, you get up near the surface of the ground and you form what is called a brick ledge. And the brick ledge is where you will start your brick work and or real stone work. And it gives it a support, almost like a footing that it sets on. And this brick ledge is going to be right below the grade of the property or the level of the ground at your home. So if you're not familiar with this, your poured foundation sub can walk around with you and the two of you can kind of determine where you want the brick ledge to be positioned. He should know this even if you didn't help him, but you want to go ahead and get the brick ledges in at this point in time. When you're doing the walls, you want to call your plumber. And you want to tell your plumber that you're getting ready to pour the walls. They're forming them up right now. Does he want to get out there and put any sleeves in the wall for any water lines and or sewer lines? And the plumber may get out there and install these sleeves. It's no big deal. Or if he'll tell you where they need to go, the poured foundation sub can install them, no big deal. But if the plumber says, no, we're running behind schedule, go ahead and pour it, and we will come back and core the wall and do it later. Well, that's okay. If they want to come in later and want to core a hole through the wall for a water line and or a sewer line, I have no problem with that. Now, they can't bust a hole in the wall with a sledgehammer. They've got to core it. The thing I don't want is for the first bill from the plumber, when I'm looking at everything, all of a sudden there's a line item, coring wall, $150. No. I'd call the plumber up and say, Mr. Plumber, I told you they were going to pour the walls. You could have come out there and put a sleeve in the wall. you chose not to do that, I'm not going to pay the $150 to core the wall. If you fail to tell the plumber you're pouring the wall, then you are liable for that $150 coring charge. You want to make the poured foundation sub install sleeves at the base of the wall where you're going to be running any drains for your waterproofing system. If you tell the if you tell the poured foundation sub this, they know what you're talking about because they understand how that pipe will go around the base of the wall. And when you come to a T-wall or you come to where a garage is, they'll put a sleeve there on the footing where that pipe is able to go through that wall, and you don't have to snake the pipe all the way around that wall. You'll see pictures of this at 24/7, but even if you have no idea what I'm talking about, if you just tell the poured foundation sub this, they'll know what to do. You want to make sure they did run the grounding rod up from the footing through the wall, sticking out of the top of the wall. And you want to note on your drawings the location of that grounding rod. You'll get your walls inspected if that's required in your area. Even if it's not required, you may want to hire one of these outside firms just to check it out on your behalf, just so you know everything's okay before you pay the poured foundation sub. They will pour the walls just like we did in the crawl space. I recommend they use a vibrator, especially on a full basement, because when they pour those walls for a full basement, if they don't use a vibrator, you see a lot of honeycombing in those poured walls. And that vibrator will minimize that honeycomb in the wall. When they finish pouring the walls, and again, they'll probably use a pumper truck in order to pour all the walls at one time. They'll set those mud seal anchors or the anchor bolts. They'll let the wall sit up overnight, and then the next day they'll strip all the forms. When they strip all the forms, you need to patch and repair any honeycomb or any cold joints that you see in the walls. Then you'll have your surveyor out there to do a foundation survey to verify the foundation has not crossed any building lines, setback lines, that it is built according to plans, it's the correct length, width, and the top of that wall is plus or minus a ½ inch in level. And if this goes through okay, then you're free to pay the poured foundation sub their money. However, you may need to wait until you get a draw from the bank before you pay them. As in the crawl space, get a container out here, and as they strip all these forms, as they strip the footings, all this scrap material, they can throw it in the container to keep your job site nice and neat, and is their responsibility to get all this stuff up and throw it in the container. About the same time you're pouring these walls, or shortly thereafter, if you have any retaining walls that are drawn on your site plan, now is a good time to get in these retaining walls. And if you remember from the cost cutting area, instead of going with a poured solid concrete wall, now there may be situations where you don't have adequate room for a modular block wall and you would need to go with a poured wall. They can do this at the same time they're doing your foundation wall. But a poured solid concrete wall, when they finish, it would be ideal if you could stucco it or cover it with brick or rock, which costs more money. But that poured solid concrete retaining wall can be very, very expensive. I want you to seriously look into the modular block wall, which you see in a lot of commercial work. You also see now in a lot of residential work. You'll see pictures of it at 24/7. And the modular block, it already has kind of a finished face to it, so you don't have to cover it with brick or stucco or stone. And that modular block wall is much, much, much more cheaper than a poured solid concrete wall. And they look great. You can get different colors and textures and stuff like this. So look into that. But now's the time you want to be getting in these retaining walls.